Hello there, and welcome back for another video. This one is more definitions, but I hope to also show you some interesting video clips and things that will make it a little more interesting, I hope. All right, the first thing we need to look at, I'm on page 37 of the student text, and if you are following along in the textbook, if you want more reading on this, it is 89 to 92. So the first thing we need to define is an acid. And an acid is a substance that lowers the pH of water when added to it. So if you put an acid in water, it's going to lower the pH. And we're going to look at this scale in just a second. Let's just get our definitions and then we'll talk about what this is actually saying to us. A base is the opposite. It is a substance that raises the pH of water. I don't think I've ever taken a science test, a general science test, without seeing the pH scale. So I wanted to at least show it to you and help you to understand how to read what it's saying. So if you need to pause the video, go ahead and do that, and then we'll take a look at this pH scale. Okay, here is an example of the pH scale. And you see that low numbers are acids and high numbers are bases. You go from 1 to 14. So that is the maximum and the minimum for the pH scale. Neutral is 7. It is exactly in the middle. So let's take a look at what this is saying to us. Notice that pure water is neutral. It's neither an acid nor a base. It is neutral. As you go down the scale, so let's move down toward 1. A pH of 5 is human urine. So when you go to the bathroom to urinate, your urine is acidic. It is more acidic than water. Compared to water, it is 2 points more acidic. Tomato juice has a pH of 4, and your stomach, that's atomorphine, gastric, that means stomach. So your gastric stomach juices has a pH of 1. That's getting down there. That is a very strong acid that can do a lot of damage. That's why you can get ulcers if you have issues with your stomach lining. We will add that morpheme in just 1 second. So what if you move toward the high end, toward the bases? Remember, water is neutral. Your blood is almost neutral. It has a pH of 7.4. I learned 7.5, so this is a little bit less than what I've learned, but in that area, it's almost neutral. Hand soap has a pH of 10, and bleach, household bleach, has a pH of 12. These substances will feel oily on your hands. They have a very distinct smell sometimes. So bases are very important, especially in household cleaners. That's probably the most practical use of a base that I can tell you. But I'm curious, let me look at my textbook just a minute, because I'm curious if it goes into, it really doesn't. It's more about some things that are coming up. But I did want to show you the pH scale just so that you could see what it looks like, what it's talking about. Okay, let's go back to the morphemes page. I know this is annoying, but it's going to help you if you learn these morphemes. Gastric is stomach. And one way to remember that, if you get gas on your stomach from eating certain foods, gastric stomach. You may have heard the term gastric reflux. If you have heartburn a lot, that's where those acids are coming up into your esophagus. It's not very pleasant, and it can cause some serious health problems. So if you have that condition, make sure you mention that to your doctor. Okay, the boiling point. This is a point at, it's a temperature. Whoops, I'm still on shape tool, sorry. It is a temperature at which a liquid changes to a gas. So liquid changes to gas. If you imagine a pot of water on your stove and you see that water boiling, it boils harder and harder, and then you start to see the steam. That's the gas. A liquid is changing to a gas. For water, which remember is pH neutral, this is 212 degrees Fahrenheit or 100 degrees Celsius. If you are familiar with the Celsius scale, I'll try to give you both of those so you can know how they equate. Okay, the next one is a colloid, and let me give you a sound spelling for that. It is a colloid. Colloid. And this, to begin with, is going to be a tough definition, so just hang with me here. It is a heterogeneous, you might be thinking, what in the world is that? But we'll get there. It is a heterogeneous mixture that does not settle or separate on its own. Okay, colloid. And I'm going to explain heterogeneous to you in just a minute. That's actually going to be a morpheme, but we'll add it in 1 second. To condense is to change from a gas to a liquid. So this is what's happening if you have, let's say that there is snow on the ground at your house. Lots and lots of snow. And it's very, very cold. What happens if you make a pot of soup in your house? So you turn on the soup, the kitchen gets all warm. What happens to your windows? They condense, they fog up. Anytime you are seeing fog, that is condensation. So associate condensing with fogging. And to freeze is to change from a liquid to a solid. You see this happen all the time. If you put ice cubes in the fridge or in the freezer, when that temperature for water hits 32 degrees, as it's falling, that liquid will start to change to solid. Or 0 degrees if you are used to the centigrade scale. Okay, a gas is the state of matter and I need to check my definition on this one. I'm trying to use the definitions that are in your book, so we're not getting more than one. But bear with me just a second, because I think I have written mine down incorrectly. So, well, I'm so sorry. I'm looking. I think they must be at the beginning of the chapter. There is very good practice in this book. If you are working on your high set especially, this book is awesome. So, here we go. I'm so sorry. I just want to be sure that I'm giving you the same definition that they are. Yes. It is the state of matter that takes the shape and volume of its container. And I've given you a picture so this will be a little more clear. And let's just zoom in. If you need to stop your video, that's fine. But let's zoom in right here. What you're looking at are some molecules of gas. So this is a molecule of a gas in a container. And you see how those molecules spread out and they take the shape of the container. They are confined by the container. Okay. All right. The next two terms have morphemes. We need to mark hetero and homo, or in this case, it's going to be pronounced homogeneous. A heterogeneous, and let me sound that one out for you. Het, a, ro, hetero, G, ni, us. Heterogeneous is matter with a non-uniform, and that means that it's not even. Uniform means even. Non means not, so it's a not uniform composition. And I'm going to try to find a picture of this for you. And let's look at homogeneous. Now this looks like homogeneous, and I've heard people pronounce it that way, but the pronunciation is ha, ma, ja, nus, homogeneous. Homogeneous means the opposite. It's matter with a uniform composition. And guys, I'm going to have to stop this video. I am getting a little bit of an asthma going on, so I want to not make that worse. I will be back with you in the next video.